Good morning, students. We completed our first chapter in physics, that is electricity. Now we are moving to a second chapter, that is magnetic effect of electric current. Look at the chapter name. We have magnetic effect of electric current. See, we have again here electricity. That means it is a continuation of our previous chapter, what we learned about electricity, right? So just try to recall, we studied effect of electricity. Under that we have three things, that is heating effect, which we learned in depth in the last chapter only. Other than that we have magnetic effect and chemical effect. So here the magnetic effect which we are learning in this chapter. So this is nothing but continuation of electricity. So once in a while we keep revising the electricity chapter. Okay. So today let us start about this chapter. See, magnetic effect of electric current. We have two terms in the chapter name only. One is magnet and another one is electricity. So the chapter tells that there is some connection between magnet and electricity. Right? The chapter name itself suggests that there is a connection between magnet and electric current. So let us understand what type of a connection they both have, and it was discovered by which scientist. Okay, there was a scientist whose name is Hans Christian Ørsted. This Hans Christian Ørsted, he tried to gauge what is the interconnection between these two, that is magnet and current. So let us see through an experiment or through an activity what was the statement given by this scientist. So first he took a general electric circuit. Let me draw that one. See. So this was the circuit which consists key and a battery, and current flows from positive terminal and return back to negative terminal, and this is our ammeter, and we have a resistance, right? And there are two terminals between X and Y. So here this scientist connected a copper wire with this X and Y terminal. There is a conductor. So this is our copper wire. So what was this next step means? Let us take a paper, a cardboard sheet, and kept perpendicular to this copper wire. So let us take like this. So he kept that paper perpendicular to copper wire. While examining, we can take some stand with the help of that, we can place this sheet. Okay. So what happens here is, we took a sheet which is placed between X and Y terminal, that means with copper conductor, right? So what was the next step is, let us take one compass. See, compass looks like that, which has a small needle. There are two ends, right? One end shows north and another end shows south. So this is also made up of a small magnetic piece. So what he did is, he took that compass and kept on a sheet, and that is next to the copper wire, next to the conductor. So as I said, we have a needle which indicates, so my arrow mark indicates north and the other end indicates south. So understood? So he kept here. So this was his experimental setup. So what was the next step means, when he turned on the switch, that means when the power started to flow, when the electricity started to flow through this conductor, that is copper conductor, he observed that a sudden deflection in compass. Now what is deflection is nothing but movement of this needle. So once again I repeat, after setting the experiment with the devices, when he switched on the current, he observed that immediately there is a deflection in needle. So remember, only when we turn on the switch, that means when electricity passes in this conductor. So from this experiment, he concluded that current carrying conductor will show magnetic effect. So that means when current passes through this, the needle started to deflect. the needle started to deflect. That shows there is magnetic effect in this current, in this conductor. Only when electricity is passing. I hope you understood. Now let us see how it works practically. Look at the circuit diagram, the circuit connection. It is exactly how we drawn on the board. So we have all the components in a circuit. So here you should mainly observe that the compass needle which is placed on a sheet. So here just observe the direction of that compass needle. This is before on the switch. So observe that compass needle. Now let us on the switch. So you should observe what happens to that compass needle after on the switch. So here we are on the switch. Now look at the needle inside the compass. Its direction has been changed, and this is what we learn through this activity. So from this video which was just we saw how it worked practically, we understood that what was the experiment, right? So from this, our scientist Hans Christian Ørsted states that a current carrying conductor, there is a copper wire here, behaves like a magnet. Only a current carrying conductor. Current carrying conductor is must and should because it behaves only when electricity passes. When the switch is off, there is no deflection in the needle. So hence he states that a current carrying conductor behaves like a magnet. So this was given by Hans Christian Ørsted. They may ask you what was he discovered through this activity, then you should state this, or else what was the theory given by Hans Christian Ørsted. Means you must remember, because later on we will find few more scientist names. So this is the scientist who gave interconnection between magnet and electricity. So once again I repeat, remember, he is a scientist who gave interconnection between magnet and electric current. So I hope you understood this part. Now here we are observing about magnet, right? So let us see what is magnet. So which we already know. Just for recalling purpose, let us see an introduction about magnet. What is magnet? Magnet is something which has a field to attract or repel another material which is magnet in nature, right? So usually magnet attracts iron. So this comes what is magnet, and what are the properties of magnet? There are two important properties of magnet which we should remember. Those are the basic things. One is magnet has two poles, right? What is that? One is north pole and another one is south pole. And one more important property is, we already know that like poles will repel and unlike poles will attract. That means if north and north, same poles, that is called as like poles, will repel each other, and opposite poles, for example north and south, will attract each other. So these are the properties and about magnet. And what was the introduction about this topic, that is current carrying conductor will show, it will behave in magnet nature, right? There are different types of magnets in its appearance, okay? So there are so many. Just look at this diagram. We have bar magnet, we have horseshoe magnet, we have disc magnet, and many more. So mainly in this chapter we are using two types of magnet, that is bar magnet and horseshoe magnet, for our rest of the activities. So what is bar magnet? So bar magnet means it is a rectangular object composed of iron having permanent magnetic property. Having permanent magnetic property, and this rectangular object. See, a bar magnet looks like this. This is a bar magnet which has two poles, as I said. One is north and another one is south. And we observe one word here, that is permanent magnetic property. Once if we complete one class, this today's class, and when we start tomorrow's class, we will come across one is permanent magnet, another one is artificial magnet. So after a few more experiments, I will explain what is artificial magnet and permanent magnet also. Right. So this is a bar magnet which has permanent magnetic property. So look at this diagram, it will look exactly like this. So we have an in-text question, that is, when we brought a compass near to bar magnet, it will start showing deflection. And why that will happen? See, as I said, bar magnet, what is this? Deflection, which have a needle, is nothing but it is also a small bar magnet. So when that will brought near to this bar magnet, what happens? It will start moving. That means it will show its deflection. That is due to both magnetic field lines will try to interact with each other. So that's why when it is brought near the bar magnet, it will show deflection. And the same question I will give in the homework, try to answer. Okay. Now we understood bar magnet, which we will use in the next two or three activities. So till now we understood what was given by Hans Christian Ørsted and what is bar magnet. Now to understand what is magnetic field, and magnetic field lines, let us go through an activity and let us define what is magnetic field or magnetic force and what is magnetic field lines. Now we know what is bar magnet, right? So it was like this, north and south poles. So let us understand one activity. Let us take a paper, a cardboard sheet. In between or in center of the paper, we should place this bar magnet. So just think this is our cardboard sheet. In the center of the cardboard sheet, I am placing the bar magnet. So the next step is iron fillings. That is nothing but a small pieces, grinded pieces of iron. So sprinkle those iron pieces around the magnet, just like salt sprinkling. Now what I did, I took a paper. In center, I placed bar magnet and I started to sprinkle the iron fillings. So when I just sprinkle the iron fillings, just tap the paper. Just a small tap. What happens? The iron fillings start arranged to themselves. Okay. Now let us see how this practically works. As I told, at the center of a paper, we took bar magnet and we are sprinkling iron fillings. Now you should observe carefully that those iron fillings are arranging themselves or aligning themselves with some pattern. So observe carefully, they are arranging like some curved loops. That is, they are originating from one end and going to another end. So now let us see another one. So same thing here also. Iron fillings is sprinkling on a bar magnet and we are getting here the exact picture how we are learning, that is magnetic field lines around a bar magnet. Now we saw that the iron fillings start arranged themselves in this manner, right? There are more field lines. We will start like this. This is what we observed in the activity. So from this, let us define what is magnetic field and what is magnetic field lines. So we observe this diagram, we know till some boundary, the iron fillings start to arrange themselves. So make sure till some certain boundary. So magnetic field can be stated that the region around a magnet, in which magnetic influence can be experienced. So only some particular boundary it will arrange themselves. For example, from here to here, if we keep there those iron fillings, it won't attract. So only some particular region, it will show its magnetic influence. When what happens then? Only to some certain region it will show its magnetic influence. So that particular thing is we can call it as magnetic force or magnetic field. In other words, we can define it as the area around a magnet in which magnetic force can be obtained is called as magnetic field. Now I hope you understood. Now what about field lines? We observe that the iron filings arrange themselves or they align themselves in some particular pattern, some particular lines, right? So these lines are called as magnetic field lines. So let us recall what is magnetic field and what is magnetic field lines. So magnetic field lines is nothing but the iron filings align themselves in such a pattern, and those lines will call it as magnetic field lines. And what about magnetic field? And magnetic field is the area around the magnet in which there is magnetic force. The area around the magnet in which there is magnetic force is called as magnetic field. Now we understood both the lines. Now this diagram somewhat looks like this, right? Same thing happens. If we know this, we have north and south pole. And what we should study next? In which direction these lines are traveling, whether they will travel from north to south or south to north. This we should study. Let us understand this through an activity. And these are nothing but we are studying about these are magnetic field lines. So next step is we are studying the properties or characteristics of magnetic field lines through an activity. So again on the cardboard sheet we took a bar magnet which has north and south poles. So let us place an compass next to each pole. For example, we are taking one more compass on either side. So as I told, the arrow mark indicates north and the next one is south, right? Now, after placing this, what happens? It will start showing deflection, right? This compass start showing deflection. Now can you guess in which side it will show the deflection? Think. I will give 3 seconds. Think whether it will show this way or this way. So understand. Earlier only I explained one question that why the needle in a compass show deflection when we take near the bar magnet. And we have, as I said, north and south. So we have north and north. Will this deflect towards this way? No. Why? Because just recall the properties of magnet about the magnet. What says magnet? When like poles come each other, they will repel. So what happens? If this turn like this, we will get north. Understand? When I brought this near this end, it will, if we show this deflection, we will get north and north, which is not possible because like poles will repel. So what is the possibility now? We will get deflection like this, south and north, because south is what? Unlike poles which will attract, and this is what? Like poles which will repel. See, this is the first step we should understand. If we know this, then no need to worry about the rest of the activity, we can easily know. So now we got the direction, that is south facing towards this end of a pole. I hope you understood. Let me rub this one. So what happens when I take a needle? It will start showing this way, that is south and north. Now the same thing we should repeat in some certain boundary, because magnet will show its force or its field only some certain region. So we should take the compass and we should keep on placing everywhere, and we should note down the direction. So same thing, we will get like this, we will get like this, we will get like this, something will happen, and at then what happen? If we keep like this, the same bar magnet, it will show like this. It is north here and south here, right? Because opposite unlike poles will attract. So from this we understood that we will get, let me draw the same thing here, north and south. So from this, see the direction, north is facing this way. That means we will get like this alignment right, which we saw in earlier activity. We will get this shape of magnetic field lines, and from this compass and bar magnet experiment, we will know that north will start showing this direction and it will come to this south end. That means magnetic field lines start emerging from north pole and then to south pole. Understood? Look at this diagram and see that it shows that field lines arises from north pole and end into south pole. Field lines arises from north pole and end into south pole. So same things will happen. Same thing will happen. You can't show all the alignment, right? So let us show 2 or 3 lines, and the rest of the them let us show it will go like this. But here we should show the direction. So from north to south. What happens here? Same. North to south. So here what happens? This will come this way. So everything will have same, and here this way, right? This is was the direction. Now what is the first property we can state through this activity? That is, the field lines emerge, field lines arise from north pole to south pole. And remember, this is happening outside the bar magnet. So let us learn what happens inside the bar magnet also. So what was the first point? The field lines arises from north pole to south pole outside the bar magnet. So let us say, take the same thing, so which we got like this, that is north to south. And let me show only one magnetic field line. So then what happens? It will flow from here to here. Inside it happens. So what happens? Then the direction, will come like this and it will go back like this. Now observe in the outside it's showing north to south. Then what about inside the bar magnet? Just only concentrate inside this magnet. It's showing the direction from south to north. Right? This is happening exactly opposite from the outside. So we have 2 points here, that is outside the bar magnet, magnetic field lines flow from north to south. This is outside. Now what happens inside? Inside from south to north, inside the bar magnet. So I hope you understood both the points. Usually they will ask for 1 mark or in an MCQ question. So we understood 2, outside and inside, what happens. Now to show this complete direction of the magnetic field, we got some circular loops, right? Hence we can state that, so from this we can state that field lines are closed curves which result in the formation of continuous or running closed loops. So this was the next point which shows continuous or running loops about field lines. Now I hope you understood 3 points. Now let us understand 2 more important points. See, now we will observe the complete diagram. So just observe where we observe more field lines. So we have only 2. For example, if they have a gap in between them. But just observe at the ends of the poles. Observe only at the ends of the poles. So we observe there are more magnetic field lines in the end. So this is nothing but the strength of a magnetic field lines are more where there are more magnetic field lines, and more magnetic field lines will observe at the end of the poles. It may be north pole or it may be south pole. So the relative strength of magnetic fields will be more where the more magnetic field lines will observe. And the next point is, so we have a magnetic field lines. If we take another magnet, we will get the same lines. But remember, those magnetic field lines and the magnetic field lines of another magnet, they do not cross each other. That means they do not somehow intersect with each other. What happens when they intersect or when they cross with each other? What happens? We have only one compass which have only one north end, which has only one south end. When they come to contact with each other, when they cross one another, it should show two north direction and it should show two south direction, which is not possible. So conventionally we can say that magnetic field lines do not cross with another magnetic field lines. So if they ask for give reason, you should mention that if they come with one another, then we should, that the field line should possess two north poles and two south poles, which is not possible. And conventionally we can say that the magnetic field lines do not cross with one another. So these come under properties of a field lines. Now let us quickly recall what are the characteristics or properties of field lines. So the characteristics are, field lines emerge from north pole to south pole, and that is happens outside the bar magnet. What happens are inside? Inside the field lines will flow from south to north. And the next one is, field lines are closed curves. That is why due to formation of continuous or running loops. Okay. And the next one is, field lines are closer in stronger magnetic field lines. So where we observe stronger magnetic field lines? On both the sides of the poles. And it is called as relative strength of magnetic field lines also. And the next one is, no two field lines are found to cross each other. Why? Because if they cross each other, they should possess two south ends and two north ends, which is not possible. Therefore, no two field lines are found to cross each other. So usually, what type of a question will get means directly they will ask, state any two or three properties of a field lines, or they will pick this one, that is the direction of magnetic field lines inside or outside, or else give reason. Field lines are closed curves. Why? So we should give due to formation of continuous or running loops. Or the one more important question, that is from this part. No two field lines are found or cross each other. Why? You should give reason. Then you should give that if they cross each other, we should have two north and south ends, which is not possible. So conventionally we can tell that no field lines will found cross each other. Other than this, we have one more property of a magnetic field lines is, magnetic field lines have both magnitude and direction. So this is again an important topic. So before this, you should know what is magnetic field and what is magnetic field lines, and we should able to draw the magnetic field lines around a bar magnet. So this is again expected question. Draw the magnetic field lines around a bar magnet. You should draw the field lines and you should show the direction. You can neglect to show the direction inside the bar magnet, but outside the bar magnet you should show that it flows from north to south. Understood? So now let us take some 3 questions in the textbook. So we already learned that why does a compass needle get deflected when brought near a bar magnet, right? So next there are 3 more questions, that is in text question. Draw magnetic field lines around a bar magnet, which I just explained now. List the properties of magnetic field lines. You should able to list any 4. Okay. Next, why don't 2 magnetic field lines intersect each other? And this was that we should understand this one. So we understood all about these things. Now let us see magnetic field due to current carrying conductor. So today I will explain that, but based on that we will learn in the next class. So again we will understand that through an activity. So here, magnetic field due to current carrying conductor. Did you just familiar with this sentence? Yes, of course, because this was what we found from the first activity of this chapter, right? So when we kept compass next to the conductor and when current started to flow, we got a deflection. That is nothing but magnetic field due to current carrying conductor. So here again Hans Christian Ørsted with the same continuation of that experiment, he gave one more statement. Let us understand what was the next statement he gave. Okay, so here as we know that this is our first circuit. Observe this one, this diagram. Here we have a battery on the plug key, and this is two terminals. In between we have a copper wire. So now this is same what we studied in the first activity. Now if we keep a compass, it will show the deflection when electricity start to flow. But let us keep the compass parallel to the conductor, that is this X and Y copper wire. So let this be north and let this be south, as I said already. So we know that this is the direction which we will get. This is north, south and west and east, right? So now here we should observe this battery or a cell. So as I said, the experiment is set up like this. So when I switch on the circuit, what happens? Electricity start to flow, and we know that there is a deflection in this compass. So what happens here, when I just switch on the current, we got a deflection like this. That is, it moved in this way. That is from where, if we have north and south here, what happens? The needle show deflection towards this way, that means towards east. So this was he observed with this first setup. Now he took the same circuit. So same here also we have X, Y terminal, in between a copper wire is connected, we have a key, and observe here instead of taking the same way, he just reversed the cell. That means negative here, the negative this way and positive terminal this way. This is positive, this is negative. Here this is positive and this is negative, and current flow from this way. So here what happens? The current start flow from this way. So what he did is he just reversed the battery. Now same thing will apply here. We took a compass which was first like this, north and south, and when we switch on this, what happens? We got a deflection this way. We got deflection this way. That means what? This way, that is towards west. So very simple. So from this he gave one statement. I hope you understood both the experiment right. So we got the deflection with first setup towards east when we have this type of a battery. When we reversed the battery, we observed that the needle showed deflection towards west. So through this activity, he gave one statement that when a battery is reversed, when a cell is reversed in a circuit, the deflection of a needle also get reversed. So I hope you understood. When the battery is reversed in a circuit, the deflection in a needle will also get reversed. So in this class, just we should understand that as a battery reversed, the deflection will also reversed. Based on this concept, let us understand 4 more activities or 4 more subtopics in our next classes. Okay, so today I'll stop here. So you should recall in today's class what we learned about magnet and the properties of a magnet. Then from first activity, from what type of activity, Hans Christian Ørsted state that current carried conductor shows magnet. Then we understood magnet field and magnetic field lines through an activity. Then we understood a bar magnet producing magnetic field lines and its properties. Later on, this current, see here they won't ask you to what was the setup you made and what was this procedure and all. So all you need to remember is when a battery is reversed, the deflection in copper is also reversed. Only one statement you should remember. So in next class we'll continue from today. So write notes and solve all the homework questions. If you have any doubt, you can ask me. Thank you.